Well, good morning, friends. We are starting week 3 of this adventure, and it is Monday, April the 6th. I kind of do that probably more out of my benefit than yours because I've got to kind of know what day it is. So, a couple of housekeeping issues before we get done. Again, I posted the week at a glance on Blackboard announcements, so you can kind of look and see what this week looks like for you and plan accordingly of what you're doing outside of this. So we'll have a quiz today and we'll have a quiz on Friday. So those due dates are listed there. We're starting a new chapter. We finished our test on Friday. I still have one person that never contacted me. So if you are that person, you should probably contact me because you currently have a 0 in the grade book. Your tests were pretty comparable to what you had done previously, and so as I went back through and looked at those and uploaded them into the grade book, grades as of this weekend are posted on Blackboard to your current grade, and basically I will do that every weekend. So it will be, I'll change it every weekend as your current grade. What else was I going to say? I forgot. It'll come to me. I probably should have made a list. Okay, we're going to start chapter 4, and chapter 4 and 6 are the last two chapters that we're going to do. So when we look at the grand scheme of things, we actually have 6 sections left to do in this class. Okay, 6 sections. So we are almost there. So hang with me. This chapter is very different in the fact that some of you guys may have never seen this information. So if that's you, make sure you reach out if you have questions. So section 1, we want to talk about inverses. And what we're leading up to is in a couple of days, we'll talk about inverses in terms of logarithms and exponentials. So today's kind of some beginning information for that. So inverses, basically, they two functions that undo each other. So think about the squaring function and the square root. They undo each other. Addition and subtraction, multiplication and division, they undo each other. So those are what we know as inverses. Now, if you're given 2 functions, you can determine if they are inverses of each other by doing our composite functions from chapter 2. So f composed of g, g composed of f. If you do both of those and they both equal x. Now, let me be very clear. It's not that they both equal the same thing. It's that they both literally equal x. Okay? So in this first example, I do f composed of g. So I start with f, and everywhere there's an x, I put in my g function, and then distribute 2/3, and then simplify, and I get x. Go the other direction, g composed of f. Substitute in my f function, and I get x. So because they both equal x, they are inverses of each other. Okay, they both equal x. So second, another example, f of x is equal to 3x, and g of x is equal to 1 over 3x. So f composed of g, when I substitute in, I'm given 1 over. What's left I have is 1 over x. So 1 over x is not the same as x. So because it's not equal to x, they're not inverses of each other. You don't have to go ahead and do g composed of f, because once 1's not equal to x, they're not going to be inverses of each other. Okay. When we look at graphs of composite functions, graphs of composite functions, the first thing to note is graphs of inverse functions, graphs of inverse functions are symmetric about the line y equals x. So the line y equals x is the line that cuts the first quadrant in half and the third quadrant in half. It's the diagonal line. The slope is 1. My y-intercept is 0. Okay, so that's what y equals x is. So it's a mirror image across y equals x. So one side, this side, should be a mirror image across to the other side. So to do this, you want to interchange your points. So when you have your points on your original one, you have x, y. You then want to flip them to become y, x. Now, do not change the signs. Do not change the signs. I cannot push that enough. So in the black here, I have my 3 points on my original graph, 3, 1, 1, 0, and 1/2, negative 1.5. So interchange x and y. So I literally want to just flip them, okay, flip them. So 3, 1 becomes 1, 3, 1, 0 becomes 0, 1, 1/2 becomes 1/2, negative 1.5 becomes negative 1.5, a half, okay. So when you plot those points, again, where it crossed the x-axis, it's now going to cross the y-axis. Okay, they should be mirror images across there. Now, also, if you fold your paper along the line y equals x right here, it should also, if you put it up to the light, they should also be right on top of each other. And sometimes that helps when you're graphing them. So interchange x and y. So another example, I have my red line through here. Sorry, that keeps popping up. My red line through here. I get my points off of my original graph and then interchange x and y. So then graph them and it should become this green line right here. Now if you'll notice this big star right here, so where your original graph crosses your y equals x line, that is also where your inverse graph should cross. So that's a point where both of them are going to cross and intersect. So again, to graph inverses, you want to interchange x and y. Do not change the signs. Okay, the last thing about inverses is how do I find an inverse? How do I find an inverse? So again, we want to find an inverse. There's 4 steps for you. So first of all, you want to replace your function name with y. So this can either be f of x, g of x, h of x, any of those that we've worked with previously in chapter 2. So replace it with y, and then interchange x and y. So again, where there's an x, put a y. Where there's a y, put an x. Solve for y, and then replace with y with this function notation right here. So f negative 1 of x. So this is what is denoted as inverse notation. So if it starts f of x, you want to end with f negative 1 of x. If it starts g of x, you're going to end with g negative 1 of x. If it starts h of x, h negative 1 of x. So it's just denoting our steps. Okay, it's just denoting that your final inverse. Okay, I tried to color code these steps for you and label them as to, sorry that one didn't there yet come out very good. So the first one, find the inverse function of g of x is equal to 3x plus 8. So the first thing is change g of x to y. Interchange x and y is step number 2. So the y became the x became the y. And now we want to solve for y. So subtract 8 and divide by 3. Simplify if you can. And then the last step is to replace y with f negative 1 of x. So x over 3 minus 8 over 3. So if you think about it, in your original, you multiplied by 3 and added 8. So if you'll notice down here, you're dividing by 3 and you're subtracting 8. So inverses of each other. Okay, another example, I do not like that green pen, so I will not use it again. Sorry about that. So find the inverse of f of x is equal to 1/3 x minus 6. So again, step number 1, replace f of x with y. Interchange x and y, so y becomes x becomes y. Solve for y, so add 6 to both sides. And then to get rid of 1/3, I want to multiply by the reciprocal. Okay, so multiply by 3 on both sides. So I get 3x plus 18. And then change y to f negative 1 of x. Now the last one has a few more steps just because of there's 2 x's going on. Steps are the same though as far as the 4 steps. Step number 1, change f of x for y. Step number 2, interchange x and y. So y becomes x and both of these x's become y. That's what makes the solving for y a little more difficult. So when we go to solve for y, we have to get all our y's on one side and then factor out a y to get y by itself. And then you can divide by x minus 1. And so you're left with y is equal to negative 1 over x minus 1. And then make sure that last step is f negative 1 of x is equal to negative 1 over x minus 1. Okay, so this is inverses. So 3 things that we can do with inverses. We can determine if 2 functions are inverses of each other by doing our 2 composite functions. We can graph them just by interchanging x and y, and then we can actually find an inverse. So that is section 4. You will have a quiz posted for 4.1. It will open today by noon. Once I get this posted, I will post the quiz, open today by noon, and then from there, it is due Tuesday, April the 7th by midnight. So 48 hours to complete it. Again, if you have any questions, let me know. And reach out. I'm not hearing much from College Algebra, so I'm assuming you guys are doing okay. If you do have questions, again, remember I can do Zoom meetings with you anywhere. I can work problems with you. I can go through your test with you and answer any questions there. Please note that we will have a final exam at the end, and that chapter 2 and the rest of this information will be on it. So it is in your best interest to go back and try to correct your test and go back through that. So, and if you need help doing that, I would be more than happy to do it. So, okay, have a great Monday.